Okay, question number 16. They give you this table and you have cookies, marks, candies, coffee, or tea, right? Now, the first question they are asking for, find the probability that it contains tea given that contains mark. So let me write it mathematically, right? A is the probability of contains T, so T is for T, giving is containing marks. Are we okay? So do you remember how we did this for conditional probability, guys? We go to this set, which is the mark, and we turn it into our universal set. All right? So our universal set is 18 and 14. How many of the 18 and 14 are T's? 14. So this is going to be 14 divided by 18 plus 14. That's all that you are supposed to do. All right? You put it in the calculator, whatever it is. I don't know what is it. So 32 here, 14 over 32, but you need to reduce it to, so 14 divided by 32, that's 0.4375. So I want to figure out what the probability of containing T or marks. And here the keyword is or. All right, so whenever I write it down here, T or marks is union. Are we okay? And what I'm going to do, I'm using highlighter, right? So I'm going to go to the T group. This is a T group. And then I'm going to go and use the mark group. And this is the mark group. And you see there is 14 is double shaded. Do not count it twice. So be careful about the 14. You don't want to count the 14 two times. So this is going to be equals. Add all the numbers, 18 plus 15 plus 14 plus 7. And you notice here, I added the 14 only once. You divide it by the total. Is it the total 70? Okay. So you do that, and it is whatever it is. So let me try to put it in the calculator. All right, so this is going to be 54 divided by 70. So 07714. All right, so for C, what they are asking for C, they are asking T and mag, and the keyword is and here. All right, so what is going to be for C is the probability of T and mag, and is an intersection and mag, right? Even if you get this notation wrong, it's not really a big deal as long as you know what you're doing. So you're going to highlight the T's. Those are the T's. And then you're going to highlight the mags. And the only number you are taking is the double shaded. So before we took everything shaded with the union, now we are taking the double shaded with the and, right? And this is going to be equals to 14 divided by the total. And this is going to be 14 over 70. All right, 14 over 70. No idea. All right, for D, what we are looking for here, not containing T max, not containing T max. So you can go right away and select not having T and max. So you can select the T's. You can select the T's and you can select the max as well. Are you taking them or not? No, very good. So because they say not, you're not taking the T's and the max. So whatever left is only 5 and 11, right? So the probability that you're looking for, I don't even need to put the name on it. is going to be 5 plus 11 divided by total. That's going to be 16 divided by 70, and you do the calculation. Divided by 70, 2286. $86 to 26. Okay, good. Thank you. So how do you do this? How do you write it down? If you want to write it down, it's probability. They say T or max, T union max, and complementary, right? And by the way, you could have taken it from here as well, right? That's another way. How could you do that? You could have done 1 minus 0.7714. That's going to give you the same answer as this. Complementary, because we had the other one, right? Okay, so we're done with this question.
Okay, so it's recording again. Okay.
How we do this? So what you're gonna do, guys, is you're gonna plug it into stacked. You're gonna edit. You're gonna put the numbers here: 24,
26, enter, 24, 63,
enter,
14, 51, enter, 21, 54, and 1119. Are we okay?
You put the number there, you go to start.
That's a regular calculation. You do 1 bar and enter, L1 only, no frequency, calculate, and done. All right, so you get these values. You see here the X bar is 1922.6. Done. The median you go down. So you see the median is 2154. Done. All right. And you see here the minimum value is 1119. And you see the maximum as well all the way in the bottom, 2463. You just make a difference between both of them and you're done.
We good?
It's so simple. Now they're asking about the standard deviation. Well, the sample standard deviation, they told you 606, but anyway, we got it on the calculator anyway. So you see it on the top here. That's SX 605.6, which is 606. All right. And they're asking you to calculate the Z-score for 3000. So just plug it in. 3000 minus the mean. What is 3000 minus the mean? 3000 minus 1922.6 divided by 606 divided by radical 5, because they are 5 numbers. And you're all set. Done.
Okay, so what you're gonna do first, you need to define your formulas, right? So we defined already the Z table for the 3 reasons. Confidence interval. Every time you are doing the confidence interval, usually Z table, at least 99%. The second thing, you have sigma is known. And the sigma is going to be 113. And again, now you have the n equals to 80, which is greater than 30, right? So all of them indicate to the Z table. All right, they are all getting you to the Z table. And the best way to do it, if you are looking for the confidence interval, 95%, I'll get back to 95. So what the best way I think to do it is to do the X minus the error, the mean, and X plus the error. All right, this is X bar, X bar. Now you need to know what is the error. So the error you have to calculate it on its own. The error is going to be, that's your confidence interval, right? The error is going to be sigma times ZC divided by radical n. Are we okay? So now the sigma, we know what is it. We know sigma is 113. We know the n, what is it, is 80. And ZC here, what you're going to do, you're going to go to the confidence interval. Sorry. You're going to go to the confidence interval and the table, and you're going to look for, supposedly everybody has this on your formula sheet. You're going to do the 95%, and that's going to be 196. It's already made for you. So what you're going to do, you just calculate it here. 1.96. You do the math. So if you do the math here, this is going to be 113 times 1.96 and divided by radical 80, whatever the value is going to be, right? So let me see if I can use Desmos. All right, so what we said, 113 times 1.96 divided by square root of 80. That's 24.762, right? $24.762. Are we okay? So now what you need as well, you need the X bar. What the value of the X bar? X bar is 455, right? We good? So you're done, right? So you're gonna go back to the formula, the X bar minus the error. The mean is in between X bar plus the error. So this is gonna be 455 minus 24.762. And this is the mean, and this is 455 plus 24.762. All right. Probably I can do one of them. Is 479.762 here. And the other one, I'm going to use the calculator. Say again. 130. 430. Thank you. And you're all set, all right? So this is your confidence interval, guys. We good? All right, for B, the formula that you're going to be using is N equals sigma times ZC divided by the error, everything squared. I hope you located on your formula sheet. Now, I want to figure out what the values of this, and the sigma is going to be fixed, 113, the same one. So 113 is the same one. ZC is the same as well for 95% confidence interval. This is going to give you, going to be 1.96. All right. And the error here, because they say within 15 points here, that's going to be the value, right? 15, that's the error. Within, that means 15 on the right and 15 on the left. Okay. So then done. You put 15 here and you calculate the N, and always round up. Whenever you get a decimal, even 0.01, round it to the next number, right? So you're going to be 113 times 1.96 divided by 15. Divide by 15 and square all of this. All right, so 113 times 1.96 divided by 15, and that's going to be 14. So what you're going to do, you're going to square it. And that's going to be 218.01. So you want to round up, and the answer should be 219. Are we okay, guys, with this? Okay, again, I don't know whether I'm recording or not, so it's my best intention. I'm not supposed to say it, but anyway. All right, so anyways, what you gonna do? Again, the same thing, right? So what's it gonna be? The mean this is my formula is between the X bar plus the error and the X bar minus the error. We good? And you want to calculate the error right now. So we know, first of all, that sigma is unknown. So we know sigma is unknown. So this is going to get you to the T table. And there is another thing that the n equals to 6. So definitely this is less than 30. And this is going to get you to the T table, all right? At least one of the conditions, it should be enough. At least one of them. And both of them here verified. So we know we are using T table. So this was important to determine what table you're going to use, because the E then, instead of sigma, you're going to be, well, if I am in Z table, you're going to be sigma, but this is going to be S for the T table times the T right now value of alpha over 2 divided by radical n, all right? And we know the S is going to be this one, 20.09. We know the N, they are 6, all right? And you need to figure out what is T alpha over 2. So first of all, you need to figure out what is alpha. If you have the confidence interval equals to 90%, the alpha will be 1 minus the confidence interval, right? That's going to be 1 minus 0.9, and that's going to be 0.1 or 0.10. So this is going to imply that alpha divided by 2, the half angle, the half error, is going to be divided by 2, it's going to be 0.1 divided by 2, which is 0.05. So what I mean, if you are on the T table, one tail, you're going to be corresponding to 0.05. That's only one tail. If you say two tails, that's going to be 0.10. Are we okay? This is how you read it on the T table. Now you need another thing for the T table, you need degree of freedom. So what is degree of freedom is n minus 1, right? And what is n minus 1? That's going to be 6 minus 1, and that's 5. So you're going to be on degree 5. We good? Now you're going to go to the T table. This is your T table. Remember, you are at degree 5. Uh-oh, so much. So degree of freedom is 5. So you are in this line. And if you are looking for two tails, you're going to be in 0, 1. If you are in one tail, you're going to be in 0.05. So this is going to be the column, and you are here, 2.015. Are we okay? Now, really, you didn't have to do the alpha and the alpha over 2, honestly, with the T table. If you knew that on the bottom, you have a 90% over here. That's the confidence interval on the bottom. Confidence level. Do you see it? You follow me, right? So you didn't have to deal with the alpha anyway. You just need to read the table correctly. The confidence level is all the way in the bottom, and you follow that confidence level all the way to degree 5. All right, and degree 5, you're going to be that same number. Okay, great. So 2.015. This is going to be 2.015, and you do your calculation basically, right? You got it? No? Okay, let's see. What we said is 20 point what, guys? 0.09. We're going to multiply it by 2.015 and divided by square root of 6. That's 16.526. Yep. We go back to the formula. So the confidence interval, the mean, is going to be between the X bar plus the error and the X bar minus the error. Knowing the error is going to be 16.256. 16.256 here. The mean is right here, 163.83. 163.83. Okay, you just add it together and figure out. Added, subtracted. All right, 256, I'm going to put 0.26, and this one 0.26, right? Because only 2 digits. Okay, so there are too many numbers, 163, 83. $180.36. $147.30. Okay, you get your confidence interval, guys. All right, ready for B is no brainer. What is the point of estimates? What is the point of estimate of the mean? Well, they gave to you over here, 163.83. All right. So that's the mean X bar, 163.83, and you're all set. For C, there is many ways to do C. Honestly, it's like, all right. So see what they are saying. They are getting the value of 130. And is it 130 is a good number or not? All right. What is the likelihood that this number is going to happen? All right. Is it odd or not? All right. And yes, it's very odd for a couple of reasons. What the first reason? Without doing any calculation. That you see the interval here, the range. So the range is going from 138 all the way to 180. And 130 going to be falling here. So yeah, it's kind of odd. All right, it's outside of the range, right? So yes, it's odd. And the second thing is the same reason here for the confidence interval, 130 is over here. So 130 is outside of the 90 percentile confidence interval, which is start from 147.30 and end in 180.36. So yes, 130 is odd. All right, the likelihood for 130 to happen is very low. All right. And you are set. All right, everyone. So what you're gonna do, you're gonna start with the information that you have. So N, you're gonna be 54. It would be nice to list them. Sigma is known. All right, is gonna be 121.2. X bar is gonna be 183.9. The alpha is gonna be 0.10. And the claim here, this is your claim, right? So that's your claim. And the claim basically is saying the mean is less than 200, right? This is claim. We are okay? Now, I'm going to start with the first part, which is A, the hypothesis testing. So we have the claim already. The mean is less than 200. And this is the claim. And because it does not have an equal sign, that's going to be listed as H1, right? The 80 is ours. The mean equals to 200, right? So we are done with A. the B, what they are looking for, test statistic. So before the test statistic, you need to know what table you're going to be using, T versus Z. And because sigma is known, and we have the N is 54, which is greater than 30. This two verified. So because they are both verified, we can use the Z table. So this means I am using the Z test. All right. How many samples do you have? One or two? One sample. So it means I am using X bar minus the mean divided by sigma divided by radical N. This is your formula then. You plug the value in, that's why you separate them earlier. So this is going to be 183.9 minus 200 divided by 121.2 divided by radical 54. Now for the calculator purpose, please use parentheses. All right. And hopefully I remember 121.2, 183.9. So parentheses 183.9 minus 200, close the parentheses, divide by, open the parentheses, 121.2 divided by square root 54, right? And then go here, close the parentheses, and that's going to be minus 0.976. And this is your Z test. We good? From the Z value, that one, well, I need to round it to two decimals. It's going to be 0.98. That's the value I can read on the table, only two decimal places. So then what I'm going to do, I'm going to have to use the Z table right now to read the P value. All right, let me get the Z table, just a minute, please. All right, now I'm going to read, this is a negative, right? Now, that value over there, you always please read it on the small tail, is not the big tail. It's always a small tail. Even if you see it positive, that's mean on the right side. If it is negative, on the left side. So whenever you are reading the p-values, almost 99.99%, they are small tail side. Whenever I say small tail, you are confined to be here, only in this side. All right? So now minus 0.98, I read it 0.98, so 0.9. 0.9 is over here. And then 8 is right here. So I'm going to cross them. And this should be your value, right? 1635, right? Okay. And because we are doing only one tail, that's the p-value. So let me try to explain it again. If I have this chart, this is my normal shape, the bell shape. This is the 200, whatever it is here. Let's suppose this is a 0. And if I draw this, the mean less than 200, this would be this side, less than 200. This is going to be right here. This is the totality of the alpha, which is 0.1, right? Are we okay? Now, the alpha, I don't really care about the alpha. I know it's there. But what I care more about this value over here, which is negative 0.97 or 98. All right. This value is going to build another interval, which is this one here. Yep. So it's building another interval, which is the blue interval. And this interval is the p-value. You got it? So now, what the conclusion I could make? So remember, this is the reject. The reject on the red part, right? So what the conclusion I can make here usually is the same statement. P-value less than alpha, this is gonna give you reject. I memorize only one. So if it is true, I reject. If it is false, I don't reject. So what is the p-value? 0.1635. What the alpha value? 0.1000. 1000 versus 1635. Which one greater? P-value greater. So the statement is not correct. What the opposite of reject? Are we okay with this? So I have another formula, as a matter of fact, p-value greater than alpha, do not reject. If you want to remember both of them, that's fine. You got it? But I usually remember only one. If it is wrong, I do the opposite statement. Are we okay? So that's my conclusion, as a matter of fact. This is D. And if I'm done with D, what the statement here? Final conclusion. So final conclusion, do you have enough evidence or you don't have enough evidence? You did not reject. Whenever you reject, you have evidence, right? No evidence. Did you support the claim or not? I did not reject, right? The claim was H1 and I did not reject. So I'm in favor of H0. So do not support. Do not support the claim. This should be a standard statement, by the way. I don't really need to go back to the, if you want to go back to the question and read what is the claim, and you just say, I don't have enough evidence to support the claim that says this and that, right? Which is the mean is less than 200. All right? And that's, okay, so question 19, before starting, so maybe you wanna identify what you have the information here. So we know that N is gonna be 11. We know X bar is gonna be 20.6. We know the S is gonna be 7.8. What else? We know the mean is gonna be 18.7. We know the alpha is gonna be 0.05. And I wanna figure out what the hypothesis testing or the claim. So the claim, what the sentence that is giving you the claim? Very good. So the claim is saying that the average this band is 18.7, which is the mean equals to 18.7, and this is the claim, all right? We are okay with this? So all of this is given to me, right? Now I can start with the A. So what the A? The A is part of it, the claim. So I'm going to write the claim. The mean equals to 18.7. Do you notice here I did not write whether it's H1 or H0. Now I'm going to make a decision whether it's H1 or H0, right? So because has an equal sign on it, it will be only H0. We good? So this is your claim. Now the negation of this will be H1, and H1 will be the mean different than 18.7. You got it? So far, so good? Okay. Now, I'm done with A. Let's do B. So B, I am doing one sample. And let me... And as well, I need to figure out whether Z or T, right? So the N is 11, which is less than 30. This is good enough for me to go to the T table, right? Another thing, or I could use this S here. It's going to be 20.6. This means the sigma is unknown. And this is going to give me T table as well, right? So either statement is good enough to go to T table. So now what I'm going to do, I'm going to do the T stat. All right, the T stat, it will be X bar minus the mean divided by S divided by radical N, right? You have other values. Let's plug them in. So it can be 20.6 minus 18.7 divided by S, which is 7 right? Yeah, I made a mistake here. This is 7 as well. So 7.8 here. This is 7.8 divided by radical 11, right? It's always good to use parentheses. So let's go and plug them in. So parentheses 20.6 minus 18.7 below the parentheses divided by, I could open the parentheses again, and it's going to be 7.8 divided by square root of 11. All right, exit. So 0.80879. Well, I don't know yet. Okay, so this is the statistic value. We good? Any question? All right, what I'm going to do now, I'm not going to use the p-value. I'm going to use the critical value. Do you want the p-value?
No,
I can do both of them.
well, no, I'm asking
Mhm.
so I don't know
Okay, so if I'm using the critical values right now, so I need to calculate the T critical, right? And the T critical, in order to do this, you need to graph it. It's easier if you graph it. So if I want to graph the bell shape, if I want to graph the bell shape here, and I'm gonna graph this statement H1, always H1, right? We are okay? So H1 is different than 18.7. It means there are two tails. Some of it here and some of it here. And the sum, the area of the two tails, this is going to be the total area, which is alpha, is going to be 0.05. I'm not interested in the alpha. I'm interested in half of the alpha over 2, which is 0.05 divided by 2. And this is going to give me alpha equals 0.0250. And please make it 4 digits. Are we okay with this? So what I need the alpha, which is 0.05. This is two tails, sorry. And you don't really need to calculate alpha over 2, really. But anyways, it helps. So for one tail, I have 0.025. For two tails, I have 0.05, right? Are we clear with this? I need a degree of freedom. Remember, you are doing the t-test. So degree of freedom is n minus 1, and that's going to be 11 minus 1, which is 10. So let's go here. This is my t-table. T-table. I'm going to go with the degree of freedom 10, this one. And I'm going to look for two tails here, two tails, which is going to be 0.05, I said. And for one tail is, they should be on the same line, right? So I'm going to cross this all the way here, and this is going to go down here. So the number I'm looking for is this number. All right, 2.228. Everybody okay with this? All right, so that's the critical value. So the T here from the T table, you're gonna be 2.228. And now there is another issue here because I have two tails. So for two tails, how many critical values do you have? Two, very good. So this is T minus 2.228, and this is T gonna be 2.228, right? So there are two values. So here, make sure you put plus or minus 2.228. We good? Are we okay, guys, with this? Yes? Okay, so we get this one. We get this one. Now, I need to graph here on the same place where you're gonna be the T-stat. The T-stat is 0.8, so you're gonna be somewhere here. (0.8079), and obviously is within. So this is the threshold of the alpha, and this is do not reject, and this is reject from this side, right? So is it the t-test within reject or do not reject? Do not reject. So that's going to be your conclusion. The D do not reject 8-0. So we did not reject. I think there's another question. Yeah, let's make the conclusion anyway. So we did not reject. So if we did not reject, do you have enough evidence or no? You did not reject. No evidence. I should have taken the points away. All right. So we don't have enough evidence. Are we supporting the claim or not? You need to go back to the claim. All right. We did not reject. So which hypothesis we kept? H0 or H1? We did not reject. H0. We kept H0. So we are in favor of the claim. You got it? So this one, no evidence, and we are supporting the claim as a matter of fact. Usually we have no evidence, do not support the claim because the claim is H1, but this scenario is twisted. You got it? So support the claim or not is always depending on H0. What is H0? What is? Okay, so let's do number 20. We have all the information here. So the only thing I'm going to do here, we have the alpha, it can be 0.05. What else we might need? Degree of freedom. What's the degree of freedom here? It's going to be the minimum of the n, n1 and n2. The smallest one minus 1, right? That's going to be 14 minus 1, which is 13. Are we okay with this? All right, let's start with the hypothesis testing. We are looking for the claim. Where is your claim, guys? Is it? I mean, that's the claim, right? We are looking for that claim, and that's going to be the time spent watching television by women is smaller than men, right? So women is less than men. So that's inequality, right? So I can write it down like mu1 less than mu2. We are okay with this? So I need to write mu1 less than mu2 together. And this is going to be equivalent, then mu1 minus mu2 is less than 0. That's what I'm going to pick, right? And this is going to be my claim. Now, because there is no equal sign, this is gonna be H1, right? So H1 is this one here. H0, which is the same one, mu1 minus mu2 equals to 0, and that is not the plane. Are we good with this? Now, let's go with B. We're gonna decide what table we're gonna be using. So obviously here, the n's, N1 and N2, they are less than 30. So definitely we are using the T table. And this is good enough for us to move to the T table. Now, let's go with the T stat. The T stat, the formula for T statistics is gonna be equals x1 bar minus x2 bar minus mu1 minus mu2. And this is the collective is going to be 0, right? Here, this is going to be 0. Divide by the square root of n1 squared. No, not n1, sorry. Divide by s1 squared. Divide by n1 plus s2 squared divided by n2. This is the formula on your formula sheet, right? What you're going to do, you're going to try to plug them in. So let's see. It's going to be 12.5 minus 13.8 minus 0 divided by the square root of what we got here, 3.9 squared divided by n1, which is 14, plus 5.2 squared divided by 17. And you need to come up with a number, right? So let's try to do it on the calculator here. So I'm going to start out with numerator between parentheses 12.5 minus 13.8 close the parentheses divided by the square root of 3.9 squared divided by 14. All right, you need to use the arrow here, plus 5.2 squared divided by 17. Exit. And that's going to be minus 0.7945. All right, I hope that's the same number. We are okay? See what we're going to look for. The T critical. So for the T critical, what I need my statements, the A0 and H1, right? So I need actually H1 only. So 0 is over here. So if I'm going to do mu1 minus mu2 less than 0, am I going right or left? Because I'm going left. That's less. Less goes to left, right? So this is going to be the totality of the alpha, which is 0.05. And this is going to be the threshold where you're going to reject, right? Are we okay? So what we want to know what this number over here, that's the traditional method. That's going to be T critical. For that purpose, what I need the alpha, which is 0.05, and I need degree of freedom, which we defined is 13 earlier, right? So I'm going to use the T table, and this might take a minute. Okay, so I'm going to the T table. It's not uploading it. All right, there you go. So this is the T table. So I'm going to go degree of freedom 13. 13 is right here. And then I'm going to go with 0.05 for alpha. Alpha, one tail or two tails, by the way. Is only one tail, right? So you're going to go and look for one tail. This is one tail, 0.05. And then you cross them. And the number is going to be 1.771. We good? So you're gonna be 1.771, and because you are on the left side, so you're gonna be negative 1.771. So this is gonna be negative 1.771. I hope this is clear. Yes. Now, the time of the truth. This is critical value. The statistical value was somewhere here, which is negative 0.7945. So are you within the reject or the not reject? Do not reject. Very good. So D, do not reject 80. Do you have evidence? We don't have evidence. No evidence. Are you supporting the claim or not? So if you did not reject 80, you did reject or did not? Did not. So you are supporting 80, right? So if you support the 80, you go back. I am supporting 80. Am I supporting the claim? No, I'm not supporting the claim here. So you're gonna go do not support the claim. And here you can make a sentence. You can go back to the claim and negate the claim, right? I'm not supporting the claim. We don't have enough evidence to say blah, blah, blah. All right?